To the debate. If I were to hand you a check right now for $100 million, and then I handed you a second check for 10 crores, your brain would likely process those two pieces of paper completely differently.
I mean, I would gladly take both checks, but yes, point taken.
Right, obviously you'd take the money, but depending on where you grew up, one of those checks might feel instantly, tangibly massive to you, while the other might feel like a slightly abstract translation.
Exactly. Even though, mathematically speaking,
They are the exact same amount of money.
exactly the same. The sheer quantity of wealth hasn't changed by a single cent, and today we're exploring exactly why that cognitive dissonance happens.
We're looking at the fundamental premise of how we actually build numbers, because at the bedrock of all counting, we rely on two core concepts.
Right, face value and place value.
Exactly. First, there is face value, which is just the digit itself. A 5 is a 5. But second, there's place value, right? And that's the value that digit gains based on its position in a sequence.
So a 5 at the end of a number is just 5, but a 5 pushed, several spaces to the left suddenly becomes 50,000.
And that is the crux of it. The central question we are debating today is this. Since numbers map identical, immutable quantities in reality, which grouping methodology provides a superior framework for human understanding?
Because while a 5 is always a 5, the framework we use to structure those positions completely alters our cognitive experience of the number.
Precisely. So we're examining the structural logic of two distinct frameworks today. I am coming at this from the perspective that the International System of Numeration is, frankly, structurally flawless.
Flawless is a strong word.
I stand by it, but utilizing strict, uniform intervals of 3, the ones, the thousands, the millions, it creates this mathematically symmetrical, infinitely predictable grid. It seamlessly scales for massive quantities.
Okay, but I take the opposing view. The international system might look incredibly clean on a chalkboard, sure, but I argue that the Indian system of numeration is vastly superior for actual human comprehension.
How so?
Well, it uses a method of tapering. It starts with an initial 3-digit period like the other system, but then it shifts into 2-digit periods, the thousands, the lakhs, the crores. And that isn't some sort of inconsistency. It is a highly tuned cognitive adaptation.
A cognitive adaptation that breaks mathematical rhythm?
No, it provides an intuitive, human-scale granularity. It's specifically optimized for how our brains actually process real-world magnitudes.
Well, let me start by defending the sheer elegance of structural predictability, because mathematical systems thrive when they follow unbroken patterns. If a system introduces an irregularity, it introduces a cognitive load that serves no actual mathematical purpose.
I wouldn't call a 2-digit period an irregularity.
But it is compared to the base 10 system itself. Look, the international system is built on a flawlessly repeating triad. If you visualize its place value chart, it is entirely organized by threes. You have the ones period, right, which contains your hundreds, tens, and ones.
Right.
Then you move to the thousands period, which mirrors that exact same structure perfectly. 100,000s, 10,000s, thousands. And then the millions period. 100 millions, 10 millions, millions.
It is certainly uniform, I'll give you that. It is a perfect grid.
It is more than a grid. It's architectural perfection. Every single period maps exactly to this internal 110-1 logic. It's like a set of mathematical nesting dolls.
Nesting dolls.
Yes, the outer doll always looks the exact same, no matter how large the set gets. So if we take a 9-digit number, like 179, 605, 283, it is highly standardized. You read the period the exact same way you read the ones, just attaching a new surname to it at the end.
Sure, you just append the word.
Exactly. You say 179, and then you just append the period name, million. Then 605, append 1,000, then 283. The architectural blueprint never changes, no matter how astronomically large the quantity gets.
Okay. Well, that uniformity sounds very elegant if you happen to be a computer,
But human brains do not process massive streams of data well in endless, repetitive, nested structures. We process information much better when it's broken into highly distinct, specialized linguistic chunks.
But numbers aren't linguistics, they're math.
But we interact with them using linguistics. The Indian system's place value chart isn't breaking a rule, it is acknowledging human psychology. Yes, it starts with a 3-digit ones period, hundreds, tens, ones, but then it deliberately shifts to 2-digit periods.
Which is incredibly jarring.
Not all. The thousands period only has 10,000s and thousands. Then we get entirely new periods. The lakhs period, containing 10 lakhs and lakhs, and the crores period, containing 10 crores and crores.
But let me push back here. Why abruptly change the rules of grouping after the hundreds place? To me, that is like building a staircase where the first step is 10 inches high, and every step after that is, I don't know, 7 inches high? You are just begging people to trip over the math.
I would argue you're keeping them from falling asleep at the wheel. Look, when every step looks exactly the same, they just blur together. Let's talk about what happens when you actually have to look at these numbers on a page. Think about visual parsing.
Okay.
In the international system, you place a comma every 3 digits. So an 8-digit number, say 83,346,245, is carved into blocks of 3.
Which creates a steady visual rhythm. You see the 80 million, the 346,000, and the 245. It's perfectly balanced.
Balanced, maybe. Distinct? No.
It operates exactly like the metric system. Think about it. A kilometer is 1,000 meters. A kilogram is 1,000 grams. The International Numerical System uses that exact same base 1,000 multiplier to move from one period to the next. It is universally standard.
And the metric system is great for scientific instruments, sure, but it is remarkably sterile for daily human life. Let's look at how the Indian system hacks our visual processing.
Hacks it?
Yes, literally. Take a 9-digit number like 73,205,670.43. The commas isolate the digits into digestible pairs. You immediately see 73 crores, then 25 lakhs, then 67 thousands, then 43.
So you have a bunch of tiny choppy blocks?
Psychologists have known for decades that 2-digit visual chunks are infinitely easier to hold in short-term working memory than 3-digit chunks. It's called Miller's Law. Our brains can only juggle a few items at a time.
Right. The magic number 7, plus or minus 2.
Exactly. It is the exact reason why telephone numbers and social security numbers are instinctively broken down into pairs and triplets. The Indian system builds this psychological reality directly into its numerical syntax. By isolating 73, 25, and 67, you prevent the numbers from washing over you in this monotonous wave of hundreds.
Okay, that is a clever way to look at it. You are arguing that the Indian system optimizes for short-term memorization.
I am.
But I have to push back on the idea that 3-digit chunks wash over you. The commas in the international system act as instant magnitude anchors. If I see a number with 2 commas, I instantly know I'm in the millions. 3 commas, I'm in the billions. I don't have to scan through 4 or 5 smaller, choppy commas to figure out where I am on the scale.
But you do have to do a lot more mental gymnastics when you speak it out loud. And that visual parsing naturally dictates our linguistic efficiency. This is where the Indian system vastly outperforms the international triad.
I highly doubt it outperforms it linguistically.
Let's look at how we translate digits into speech. Having a dedicated single-word term like lakh for a 6-digit number and another single word like crore for an 8-digit number is an incredible tool for communication.
It's just more vocabulary to memorize.
But in the international system, you are constantly forced to stack structural words on top of each other. You have to say 100,000s. You have to say 10 millions. It's clunky. The Indian system gives you distinct milestones.
How is it clunky? It is totally descriptive. 10 millions tells you exactly what it is. It's 10 sets of 1 million.
Because you are making the listener do the math in real time. Let's ground this in reality with a blue whale example from the text.
Okay, the whale.
The blue whale is the largest animal on Earth, and they can weigh up to 199 tons. If we convert that to kilograms, it is 1,099,000 kilograms. Now, in the international system, you lump that into a phrase, 199,000.
Yes, which makes perfect sense.
But when you start that sentence with the words 100, your listener has no idea what magnitude you're talking about until you finish the sentence. Are you talking about 100 kilograms, 100 million kilograms? They have to wait for the suffix.
That is just how adjectives work in English.
But mathematically, it is incredibly inefficient. Using the Indian system, that exact same 6-digit number reads cleanly as 1,99,000. The split second you hear the word lakh, your brain instantly registers a 6-digit magnitude. Boom, the scale is set.
I mean, I guess if you're used to it.
It communicates the exact size through a distinct period name, rather than forcing you to juggle these stacked modifiers.
Okay, I understand the localized appeal of that, but I am not convinced because you are trading infinite scalability for a very temporary convenience.
Temporary? How is it temporary?
Yes, temporary, because numbers go to infinity. And this is exactly where the Indian system hits a vocabulary ceiling. Let's look at the greatest 9-digit number possible, 999,999,999. In the international system, it is read with a kind of poetic symmetry.
Oh boy, the poetic symmetry.
Watch this. 999,999,999.
You just had to say the word 100 3 separate times in one single number. You had to say 99 3 separate times.
It has rhythm.
If I were listening to you read a spreadsheet out loud, I would literally lose my mind trying to track which 100 we were currently on.
It is a rolling cadence. It perfectly mirrors the mechanics of the base 10 system. But more importantly, and this is the crux, it never runs out of road. My system can go on forever.
Right.
Doesn't inventing entirely new categories, lakhs, crores, and the terms that come after them like Arabs and Karabs, every 2 decimal places, create an endless vocabulary test?
Not really, no.
But think about what happens when you scale infinitely. The international system relies on that endlessly repeating hundreds, tens, ones loop. You only need to memorize one new suffix for every block of 3. Thousands, millions, billions, trillions.
Sure.
The structure of the sentence remains completely identical. But in the Indian system, you have to constantly memorize entirely new root words for every 2 decimal places you shift left.
I just don't buy that infinity is a good metric for designing a daily counting system. Humans do not live in infinity.
But mathematics does.
We live in the real world of national populations, corporate budgets, and daily commerce. The vocabulary ceiling you are so worried about is practically non-existent for 99.9% of human experience.
I disagree. We deal with billions and trillions constantly in economics.
Yes, but we don't need a system optimized for counting the atoms in the universe. We need a system optimized for buying a house or reading a census. When we talk about 1.4 billion people in a country, knowing that it translates to 140 crores makes it intensely tangible. The Indian system is tailored for the actual bandwidth of human experience, not the vacuum of theoretical astrophysics.
But that brings us down to the bedrock of mathematics. Beyond the commas, right, beyond the vocabulary words, let's talk about the absolute nature of place value, because how a system expands its numbers reveals its underlying logic. And I would argue that when you look at the expanded forms of these numbers, the international system proves its inherent mathematical superiority.
All right, I'm ready for this. Expand a number for me. Let's hear it.
Let's take the number 230586721. Regardless of the commas, when we break a number down into its expanded form, we multiply the face value, the digit itself, by its place value.
Right.
Mathematically, 8 crores is intrinsically equal to 8 multiplied by 10 million. The absolute mass of the number hasn't changed a single iota. But here is why the international system's expansion requires far less cognitive translation. Our base 10 multipliers align perfectly with our period groupings.
What do you mean by that alignment? Explain that.
Every single time you cross a comma in the international system, you are multiplying by exactly 1,000. You start with ones, multiply by 1,000, you get thousands. Multiply by 1,000 again, you get millions. Multiply by 1,000, billions. The transition is mathematically seamless. The commas are quite literally representing powers of 1,000. But in the Indian system, your multiplier jumps by 1,000 at the very first comma, moving from ones to thousands. But then, it only jumps by 100 to get to the lakhs comma,
Right.
and by 100 again to get to the crores comma. You start with a multiplier of 1,000 and then abruptly shift to multipliers of 100. It entirely disrupts the base 10 rhythm.
That is a compelling observation on the math, but have you considered how that expansion is actually anchoring the abstraction for the people using it?
Grounding a mathematical disruption? How does it do that?
By aligning the math with the culture of commerce. Look, I completely agree that 1 crore perfectly equals 10 million. 10 crores is 100 million. It's the exact same digit followed by 8 zeros. We are not disagreeing on the math itself.
Right. The math is absolute.
But expanding a number like 25,55,762 feels much more grounded to a local context, precisely because of that shift to base 100.
I'm still not following why multiplying by 100 is better than multiplying by 1,000. It's objectively less sufficient for large scales.
Because the face value of the 5 and the 10,000s place remains 5, and its place value remains 50,000. But grounding the larger digits in lakhs ties the abstract math directly to the economic fabric of over 1 billion people.
How so?
Think about local currency. Local currency is designed to fit the pockets and the daily transactions of the people using it, right? It isn't always pegged to some sterile universal gold standard. The shift to multipliers of 100, moving from thousands to lakhs to crores, isn't a disruption of rhythm. It's an optimization.
An optimization for what?
For daily life, we trade in hundreds. We think in hundreds. Chunking the upper magnitudes into pairs of 2 perfectly reflects how merchants, farmers, and students actually conceptualize escalating wealth.
Okay, so you are essentially admitting that the international system has mathematical symmetry, but you are arguing that the cultural and cognitive utility of the 2-digit intervals somehow outweighs that pure symmetry.
Yes, I am arguing that mathematical symmetry is completely useless if it causes human eyes to glaze over.
Well, let me pull back and summarize my position based on our exchange, because I think the divide here is quite stark.
It definitely is.
My perspective remains that the international system's uniform 3-digit triad provides unmatched scalable symmetry. By maintaining a strict hundreds, tens, ons internal structure for every single period, it creates a highly predictable framework.
Right.
Whether you are dealing with thousands or 100 millions, the rules simply do not change. It is an architectural blueprint built for processing infinite magnitudes with flawless consistency. It completely eliminates the need to memorize shifting grammatical rules or constantly invent new vocabulary every time you add 2 digits to a ledger.
And my position is that mathematics is ultimately a tool for human minds. And the Indian system is optimized for exactly that, the human mind.
Even with the vocabulary ceiling?
Especially with it. The 2-digit tapering, where we move from the 3-digit ones period into the specialized 2-digit thousands, lakhs, and crores, is a feature, not a bug. Complemented by distinct terminology, it offers a deeply human-centered approach.
Okay.
It breaks massive, abstract quantities into cognitively accessible pairs that are mathematically proven to be easier to read, easier to speak, and easier to hold in short-term memory. It anchors the infinite abstraction of numbers to the tangible realities of human commerce and daily life.
It really is a profound disagreement on methodology, but regardless of where we stand on the comma placements or the vocabulary, I think we both find immense convergence in the fundamental truth that sits beneath all of this.
Oh, absolutely.
Whether a comma is placed after 2 digits or 3 digits, and whether we call that resulting block 10 lakhs or 1 million, the relationship between place value and face value remains the undisputed foundation of reality.
100%. The structural integrity of base 10 mathematics does not bend to our commas. 10 ones will always equal 110. 10 tens will always equal 100. And 10 lakhs will always perfectly translate to 1 million. The underlying architecture, the actual weight of the quantity is completely identical.
It is deeply fascinating because mathematics is so often viewed by the public as this incredibly rigid, inflexible discipline, a realm of pure black and white.
Right, you're either right or wrong.
Exactly. Yet here we have a single absolute reality, the identical physical mass of a 199-ton blue whale, or the exact greatest 9-digit number of 999,999,999. And the mathematics allows for and even encourages completely diverse, brilliant frameworks for interpreting that exact same reality.
It really does. It shows that numbers aren't just cold, hard facts etched into stone. They are languages. And like any spoken language, they morph and adapt to the cognitive limits and the cultural needs of the people actually using them.
That's a great point.
There is always more to explore regarding how humans map abstract concepts to their lived experience. It really makes you wonder how many other rigid truths in our lives are actually just one of many possible blueprints.
That is a perfect way to look at it. The raw materials, the digits, the face values, never change their physical properties. A 5 is a 5, an 8 is an 8.
Yep.
But the blueprint you choose to use, whether you group those concepts in massive, uniform blocks of 3 to build an infinite tower, or whether you carefully taper them off in digestible pairs to suit the human eye, well, that dictates how humanity looks up and understands the scale of the world around them.
Absolutely.
The sheer quantity remains the same, but the cognitive elegance is entirely in the eye of the beholder. We will leave you to decide which blueprint you find to be the most structurally sound. Until next time, keep questioning the numbers.